What's going on, guys? It's Locust. Welcome back to another video. In today's video, we're going to be going over hooking functions in C++ internally. I think this is a good video because surprisingly, the videos that actually do cover this topic on YouTube are not very well in depth at all. They don't really explain what they're doing. It's kind of it's kind of just follow what you're doing, and I feel like it's very important to explain the code, because if you don't, then the person's just copying it, they're not learning. And I feel like learning is the best situation that should happen, because if you're not learning, then you're basically just copying, and how are you supposed to ever make your own stuff if you're just copying other people's stuff, So let's take a step towards learning. I'm gonna give my best explanation for everything. I'm not also like a complete I mean, I would consider myself pretty knowledgeable, but I'm not. Just remember, I'm not like a complete expert at this. Like, I understand it, I know what I'm doing, but I'm not a master of any sorts. So I do make some errors sometimes, so just bear with me. Some Roblox videos will be coming out soon. I do have an executor, I have everything. I just need ideas. So if you want, join my Discord, give me some ideas of some Roblox scripts I can make or something, teach you guys how to make. I felt like doing ESP or something, but I feel like that's just, I feel like I've already done that. It's just too broad. Maybe an updated one, I don't know. Let's just get into the video. Okay, so the first thing we're gonna do is we're just gonna create a new C++ project, and we're gonna make it a DLL. So just C++, put it on C++, put it on Windows, scroll down and select dynamic link library and hit next. All right, so we're gonna name it, I'm just gonna call it hooking tutorial. So yeah, just call it, check this box and hit create. And while this is creating, I just want to tell you guys that what you're gonna need for this is this is the tools that I'm going to be using. So I'm going to be using the tool called X32 Debug. I talked about it in my last video. I didn't use it in my last video because I decided to make these two separate videos halfway through. But this is going to be for debugging the program and putting breakpoints on certain functions and stuff like that, just to check if we're hooking correctly. Yeah. And also useful things like viewing the stack. And then we're going to be using IDA Pro. It's very important that it's IDA Pro. Like I said, you go about your own means in order to get IDA Pro. I personally know it's a lot of money. That's what I'm going to say. Paying for it seems very I won't say, I can't really say what I want to say, but go about your own means in order to get IDA Pro. That's what I'll say. As long as you have IDA Pro, you're fine. And the reason why we want Pro, I've seen some people say, why not IDA Freeware? It's because IDA Pro allows you to use the disassembler, and the disassembler is very, very useful. It gives you basically a little, like, it's not always perfect, but it gives you a best guess on what the function's doing. And it also gives you the calling convention, or a guest calling convention, which is really useful because finding them is just an extra step, pain in the ass. So yeah, get IDA Pro. And then we're also going to be using a Cell Cube, open source, nice and easy, no anti-cheat. So yeah, we're just going to be using a Cell Cube. All right, so I mean, let's just get straight into it. The first thing we actually need to do is go ahead and make a thread. So I went over this in my last video, but to make a thread, or why we need to make a thread, it's because if this is just the like, there's no actual program happening in this DLL. We need the DLL to make a program that we can execute our own code in. So in order to do that, just go above this DLL main, and then we're just gonna make a we'll make a dword main thread, and then pass a h module, and I'll explain what this is in a second. Just like this, open it up, and then right here is a switch statement. So you'll see it says reason for call. This is what it takes. All right. So what I like to do is I like to just get rid of these spaces, because I don't know, reading functions like this is just difficult for me. It's just easier to read it like this, but you teach their own. So here we go. DLL main, H module, D word, UL reason for call, LP reserve. So this is the module of the DLL main. I'll explain what an H module is in a second. And then we have UL reason for call. And if you look at this switch statement here, you have case, process attach, thread detach, process detach, right? What we want is process attach. So it's going to be process attach is when the DLL is injected into a program. Thread attach is when we create a thread. Thread detach is when we detach a thread, and process detach is when we detach from it's more commonly known as like uninjecting, so, or self-destruct. That would be a process detach. So we're gonna go process attach because this is when we actually inject our program, which is specific. So we're going to do that, and we're also we're gonna add winapi here. So this is actually declared as a thread, because if not, then you'll see that this isn't it's not going to be a standard call. So it's going to be a standard calling convention, because now this is associated with the winapi, and DLLs are all Windows. There's no DLL outside of Windows. DLLs do not exist. DLLs is a Windows concept, so just think of Windows API whenever you think of a DLL. And of course, Windows API is just a library of a bunch of functions and stuff and variables associated with Windows. So we're going to use the create thread function, and this is from process thread API. We'll go ahead, it's Windows, and we're going to look at the parameters here, and we need to pass for security attributes. We're going to pass no pointer because we don't actually need that. For the stack size, just put 0. We're not gonna worry about that. And here is where we actually need to do this is important. So the LP start address is going to be the it's the start address, so where the thread is going to start, which is going to be at main thread. So we just need to input main thread, but it's going to error us because you'll see that as you see, it says argument of type D word is incompatible with type LP start routine. So whenever you get that, you have two options. You can either do a I think it's like a fast cast, I think it's called, or something, or a reinterpret cast. So we're just going to not do a reinterpret cast, even though it's safer, because we don't really need to, because I don't think anything can go wrong with this cast. So we're gonna cast LP start routine, and to order to cast stuff, you just put parentheses and then you put the thing that you want to cast after it. So we just casted a D word to an LP start routine, which is basically just converts it. So very useful that you don't have to ever do that manually. That's C++ for you. Then we have LP void parameter, or sorry, LP parameter. So long LP means long pointer, by the way. So LP void is a long void pointer. LP parameter is going to be your parameter, or in this case, H module. Creation flags, don't worry about it. And your thread ID, but no pointer. All right, so this is a thread. Our thread has been created. Make sure to just put return 0 here. And now we should be able, whenever we inject this into a program, it should run whatever is in our main thread right here. All right, so now we're going to be installing MinHook. So MinHook is going to be the library we're going to be using for hooking. It basically handles the trampoline function and stores the original function. All that is handled within MinHook, compared to us having to manually recreate the hook, or recreate the function, sorry. So yeah, MinHook does all that for us, which is really a lot easier than hooking it manually with like code caves and stuff like that. So yeah, so let's just install MinHook. So it's actually kind of, I mean, I wouldn't say complicated, but it's kind of long to install. So the first thing we need to do is install this thing called vcpkg. You're gonna click on vcpkg with Visual Studio here, right here. Click on that, and it should bring you up to this, and this just goes over how to install vcpkg. But actually no, we're not going to use this. Sorry, don't click on this. Let's just do let's see which one we have here. I don't know if there used to be a quick start here, but I guess it's not here anymore. I guess it's a little more complicated now. Wait, I think this is it. I think this is good. Yeah. Okay. All right. So yeah. All right. This should be it. I'll have this in the description too, of course. So we're gonna first download and install Git. Just hit download for Windows. It'll come up. Hit next, all that. And then now when you open CMD, if you type in Git, you see it'll come up. Which is what we want. And then so we're just gonna copy this first thing like this, copy it, and then paste it. I'm not gonna paste it because I already have it, but you're gonna paste it. And then now that you've pasted, just paste it. So actually you can go to, I would recommend doing CD desktop. Make sure you're not in administrator, but do CD desktop and then paste the git clone. I'll just paste it just for video purposes. So paste this line into here and wait for this to finish. All right. So once it finishes, mine didn't finish because I canceled it, but once yours finishes, we're going to do CD and then vcpkg. Now, or sorry, CD. Let's see what the folder name is called. Right, I'm just gonna make a folder. All right, just go to the folder that it made on your desktop. Right. Once this is done, go to the folder it made on your desktop, and then you're gonna click up here and type in cmd and hit enter. And then you're going to run this command right here. So you're gonna just don't do this, just run this part. So copy that, paste it, hit run. Yours will run, mine won't, but yeah. So you can either do that, or if it made the folder on your desktop, you can do cd vcpkg and then run this. But yeah, and then after that, in the same directory, copy this and then paste it and hit enter. After that, you should have vcpkg installed, and now you are ready to install MinHook. So now what you're gonna do is open CMD, and if you type vcpkg, it should come up. Actually, wait, sorry, you have to go to your directory. So go to the directory where your vcpkg is. So mine's gonna be right here. And you're gonna hit cmd, or actually here, I'm just gonna open my directory that I know where it is. So, oh, sorry, I'm not on Linux. I think I'm in cd./vcpkg. Yeah. Okay, so this is my directory. Let's see if I do dir. This is my vcpkg directory. So now what I'm gonna do, what you're gonna do is once you're in the directory, you're gonna do vcpkg. And you see all the commands should come up. So vcpkg and then install and then MinHook, and we're gonna do a 32-bit game. So 30x32 -windows -static and hit enter. Oh, okay. So never mind. I think that was wrong. Sorry, I have to do x86. I forgot. So it's gonna be vcpkg install MinHook x86 -windows -static and hit enter. Now like I said, I already have it installed, but it's gonna install for you, and once it's done, then you're good. Now if any of this doesn't work, I would restart your computer and try again. If git says like not found, restart your computer and then type in git again and it should come up. But yeah, once you have MinHook installed, now we can go back to our Visual Studio, and we're gonna right click and go to properties. Make sure this is debug, and actually wait, so change this to x86 first, and then right click and go to properties. Make sure this is platform 132, debug, and we're gonna do a couple things here. So we're gonna go to advanced, make sure we click, change this to use multi-byte character set. This is just so for chars, we don't have to put an L before for like const chars. And then for vcpkg, make sure click on this. If you don't see this, then it's not installed properly, or you didn't run the integrate install command. If you need any more clarification, I do have another video called how to make a cheat for IL2CPP, and in about the first 5 minutes I show you how to install MinHook also. So if you can't install it with this video, I would try the other video. But yeah, so put this on yes, and use static libraries. You're gonna put this also on yes. Make sure this is yes, very important, and that should be it. Yeah, that should be it. So I don't think we need to do anything else. So now after you check that, if you do hashtag include, and then do this, and then do minhook.h, as you see, it will include MinHook without any issues. And if you were to type in MinHook, as you see, wh_MinHook. So if you do like create hook, you see mh_create hook. So that just means that we've integrated MinHook successfully. It's very important that you do use static libraries, because if you don't use static libraries, then it won't work, because we just installed a static library. So yeah, I think that's a pretty good explanation of what MinHook is. So yeah, let's just get into the rest of the video now. So now that we have MinHook installed, we can actually start creating our cheat. We really basically did the hard part, or the most complicated part, because everything from here is going to be smooth sailing. So yeah, we could create a console, but for the purpose of this video, I'm not going to create a console because it's pretty much useless unless you're debugging. And even that, I don't really use that console. I just use I just use tools, and then you can debug, and then you can attach to a process and you inject. But another important thing that I think we need to open is Extreme Injector. Sorry for the black screen. This is going to be what we're going to use to inject. Link in the description, of course. So yeah, let's get straight to hooking functions. So the first step is going to be finding the function that we want to hook. So for this video, we are going to be hooking the print function, right? So I'm going to give you a little rundown on how to hook 101. So the first thing we're going to do is actually open our IDE Pro, which I'm going to assume you have. Like I said, you can get a hold of it. I might actually put a link in my Discord, but for IDA, so I would check there. But yeah, you're gonna go to IDA and you're gonna hit new, and then you're going to select find where your Salt Cube installation is. I'm using 1.3.0.2, and you're gonna double click on the AC client. Make sure it's not the server or anything, and then you're gonna hit open. And if it's gonna say you own over I'm gonna hit load existing. Sorry, I just already own one. And then hit OK, and wait for it to decompile. Now the decompile time, it can take from anywhere from 5 minutes to an hour, not even an hour, like really 5 minutes to 30 minutes, depending on how good your computer is. Thankfully, I've already actually decompiled this already, so I have the file already loaded up for me. But you might not be as lucky. So as soon as we get into IDA, we're gonna go to File, and we need to actually go to Edit, segments, and Rebase Program. So we're gonna rebase this to 40000. That is 1 2 3 4 5 zeros. And make sure everything is selected. Image base, fix up the whole program, rebase the whole image. Now what this is doing is, this is the default for a 32-bit program. This is the default base address. So the base address is going to be where the address is located in memory, and where you can, what you're adding offsets to in order to find certain addresses. So we're just going to rebase this so we don't have to add this to whatever functions we find in here after, because that's really annoying, and you can just completely prevent that. So do that, hit OK, and it'll rebase the whole program. Mine's already rebased. So now that we've rebased the program, what we're going to do is go into Assault Cube, and we are going to find, since we're doing the print function, whenever you are looking for a function, you always need to find something in the game that can trigger it. Now, the best case scenario is going to be finding a string that's linked to the function that you want, because if you find a string that's linked to the function that you want, then it's so easy to find the function because it's a string linked to it, and you can search strings in IDA. If you can't, then you're going to have to look for, just use knowledge, reverse engineering knowledge and skills. But yeah, so we're gonna now go ahead and since we're doing the print function, which should be pretty easy, we're gonna somehow trigger the print. So if you hit I think it's enter, what button is it to type? I don't know what button it is to type. Oh, okay, it's T. So if you hit T on your keyboard, you should be able to type. And as you see, whenever we type stuff out, it says unarmed and then a bunch of letters. So we're gonna do something like /team, like team, right? /team, and this is a good command because it says your team is RVSP, right? And that's a string that we can find. Now, not specifically the RSVP part, that's probably not predetermined, but your team is definitely a predetermined string in the text. So we're gonna go to IDA and we're gonna do search. We're gonna do view, open subviews, and then go to strings. Oh, I just missed. View, open subviews, strings, and this is gonna take you to the list of strings here. So here you have all of your strings, and now you can search. So if you hit Control F, a little search bar comes down here where you can search pretty much everything. If I put in KS, it'll show you strings with KS. So we're gonna look for your team is. There we go. And here we go. So double click on this and it'll bring you to this. And what we're interested is the xref right here. So you'll see the xref, or if you just hit X on this, it should work. Maybe not. Okay. Oh wait, yeah, sorry, I was hitting Z. If you hit X, it'll show you all xrefs, aka all the times that this is referenced. This your team is referenced. But I would recommend just clicking here and then hitting Tab on your keyboard, or sorry, double clicking on this, and then there we go. And now we're here, and you'll have the opcode. All right, here it is, and you'll notice that there's this function under here. Let's just take a look at this. Okay, here we go. So so now that we're here, you'll see that what's going on here is it's pushing we really don't need to know this. What we're looking at is this. So whenever it says call, it means it's calling a function, right? So here's your team is, and it's calling a function right under it in both of these. Now, if you do notice, this is referenced 2 times, and this function is called after this offset is pushed to the stack each time, right? It calls this function. So this, what I think, what this is telling me is that this phrase is being pushed, right? And then this function is running after it to use the phrase that was pushed, right? Now, if you don't know about the stack and the heap, I can't really explain it in this, but there's the stack, which is the most important one, I believe, and that's just temporary storage for things. Like if you're printing something, like that phrase doesn't stay on the stack the entire time. Like I don't really know how to explain it, but there's videos on it. So see, now we're going to use this function because we know that this function is coming after this, so it has something to do with this. So click on the function and hit tab, and this is if you have IDA Pro, this is where this comes in handy. So we now have a pretty in-depth explanation of the function. So we can actually go ahead and look at this, and you can see that here's the your team is, and here is a function. So just from looking at this, I can say that this is our print function, and I can say that because it's looking like whenever you write out, like if we go to here, and if you're ever writing out prints, right? Let's say you're writing out prints, like if you're printing a function, it's print F and C, but whenever you're printing something, right? You usually do this, right? You'd print and then you put whatever text is in here. Now, if we look at IDA, it's clearly doing that. Of course, it has this, which I'm gonna assume is a formatter, and then this, which is probably also another format. Or sorry, this is a formatter, and this is an argument to accept the %s. Yeah, this looks like our print function, and to even confirm this, we're gonna click on this and hit tab. Or double click on that, and yeah, so this looks like a print function, and I can say that because it takes in a A1, which is probably a formatter, and then it takes in a const char, which is a phrase. A const char pointer is just a phrase. It's just a phrase of text. So this is definitely our print function, and now really all we have to do is hook this. So here's the address. And let's just confirm that this is our print function, right? So we can confirm this by copying this address and going into x32 debug, right? Let's go ahead and go to file, we'll go to attach, and we're going to select AC client, hit attach. And now we can go ahead and I already have some breakpoints here, so I'm just going to uncheck this breakpoint. Go ahead and hit, I think it's Control G. Yep, Control G, and go ahead and paste in the function and hit OK. And make a breakpoint at whatever we get to. So I'm gonna put a breakpoint at the function right here. Okay, so now we can go into just hit this a couple times until it says running, and now we can go into the game. And let's go ahead and run. If we hit, hold on. Okay. We can go ahead and hit T on the keyboard and type in /team. And if you see, after we hit enter, our breakpoint has popped. So, now our breakpoint has popped, and if we look over here, this is the stack. So this is our stack right here, and you can look up here and you can see that this is EDI is definitely our command. EAX is definitely the string, the argument that's going to be passed. And if you look here, you'll see that in the stack, it says your team is %s. That's passed as the first parameter, ESP. And yeah, so this is definitely our function. And if we continue, so it's running, you'll see that it would have got printed. But yeah, so this is definitely our function. We definitely do have the right function. That's just one way you can use x32 debug. And we also now know what's passed, because if we look at the stack, we can obviously see what's passed. So we can actually recreate this a lot easier. So it passed A1 and then a text char. So if we look at IDA, in A1 is ECX, right? So ECX is the same as in A1. And if we look at this, you'll see that ECX is just 1. So ECX should be useless. We don't really need to worry about ECX. So yeah, let's just go ahead and recreate the function. So let's just go to this. We can actually hit this stop and stop debugging. Let's just go to our main thread, and let's recreate it. So in order to recreate a function, we need to do type def. So type def is just defining a type. So we're gonna make a new type of our function so we can just quickly make the original print function that we can trampoline back to. So type def, and this is where IDA's decompiler is going to come in. So we can see this is the calling convention that it gets. Now I'm not going to assume this because a user call, it's a user call because of these parameters. I'm going to assume it's a fast call. You can look up calling conventions to see what I'm talking about, but when in doubt, assume it's a fast call. So that should be pretty much what you're going to do. So when in doubt, unless it's a certain amount of parameters, think of it as a fast call. Okay, so yeah, but the way you can usually tell a calling convention is the parameters it takes in, because I know these are 2 parameters and then arguments. That this is probably a fast call, not a user call. So we just know that this is an int, so we can put type def, and then we can put int. And whenever you're defining functions, it's very different than if you're defining a parameter, or whenever you're using type def too. Or sorry. Whenever you're defining a function, it's different than defining a variable. Sorry, I'm all over the place. Yeah, so it's just different than defining a variable. So you're gonna put int, and then we need our calling convention. So make sure that you whenever you're defining functions, you use parentheses. So we're gonna put our calling convention, which is gonna be our fast call, and then the name. So just gonna put print. You can put whatever you want here. This is just you're just defining a definition. So now you're gonna put another parenthesis, and this should be the argument. So we have the name and the calling convention, and we have the arguments. Now you can't just do you can't do this. This is what people get mistaken a lot. Like, this is not right. You can't do this because this is just not right. You have to, this is the way you have to define functions. This is the way it works. This is just syntax. So now we know that the first parameter is, I'm just going to put const char a1 because I don't actually know what it is. It says int a1, but I highly doubt that it's it is that, because when it's called, like here, for example, a1 is here, right? So if I'm looking at it right now and I'm seeing that a1 is actually the second parameter whenever the function is called, right? So it just makes me believe that a1 is text. So I'm just gonna think that a1 is text. So I'm gonna put const char a1, and then I'm gonna put const char pointer text, and then of course dot dot dot, because that is just following what is here. Okay. Now that we have defined this, end it with a semicolon, and use our new type to create the make a a variable for our original function, and this will store a pointer to the original function. So yeah, now we need to actually utilize MinHook. So we have to actually make our hook now. So we're gonna do int underscore and then fast our yeah. I feel like yeah, okay. Let's just define it. I think we should just call it first to make sure that we are calling it correctly, because if we're not, then I feel like we shouldn't do this until we know. So we have our original, but let's just under this we're just gonna do print, and then we're gonna do print underscore text equals, and then convert. We're gonna cast this to a print, and this is where we're gonna throw in the function address. Put OX, define it as an address, and this, now whenever we call print text, it should execute whatever the parameters at this. So now we can just do print underscore text, and input whatever we want here. Like we could input whatever we want. So we should now be this is basically, this is going to be calling the function. So we're calling a function from in game. So I'm just going to ignore the other parameter. I'm just going to throw in one parameter, and I'm going to put hello world, and then just put a blank for the next one. And let's just go ahead and build this, and let's open up Assault Cube, and let's go ahead and right click this, open folder in File Explorer, copy this, and then go and select our AC client for our game. And then we're going to go and add DLL. Go ahead and paste in that address, debug, select the DLL, and let's go ahead and open our game, and let's hit inject and see what happens. As you see, hello world is now printed. So we've successfully called a in-game function from our DLL. So yeah, that's pretty cool. But now let's hook it. So what we're gonna accomplish by hooking it is, like, if we were gonna like making our own commands is probably gonna be the best thing that we're gonna do. So if we hook our own hook our own commands, we can do whatever we like. If we hook the print function, we can do whatever we want with our own commands, because if you think of it, like if we were to put in like for example, like if you put in a command that doesn't exist, like /health for example, it'll say unknown command and then health. We can hook our print, so then whenever it runs it, we can check if unknown command health exists, right? And then we can make our own custom commands from that. So let's do that. Like let's do it. So we're just gonna close this just to not worry about injecting, and let's go ahead and recreate our let's create our hook. So we're gonna do int underscore fast call, same way we defined it, and then we're gonna call it hooked print, and then we're gonna do the same parameters. All right, and then open this up, and we're gonna do if, and see now this is where actual reverse engineering knowledge comes in, because there's two parameters that are accepted here. So let's go ahead and figure out which one of these parameters is going to be the one that says unknown command, because we can filter that out. So let's open up Assault Cube again, and let's attach. And let's just hit this button a couple times, make sure the game's loaded, walk around. Okay. And now what we're gonna do is go ahead and hook the same function. So oops, let's go ahead and grab this, paste it. Okay, and our breakpoint is enabled already. Good. Let's just type in /health, and you'll notice that if we look at the stack here, our first parameter, okay, so we have our first thing on the stack is unknown command %s. Our second thing is health, right? So what we need to do is compare the second parameter, which is health, to the text health. So if our second parameter is health, so these two are the actual commands we put in. This is the actual command that we're trying to run. This is just telling us it doesn't exist. So a second parameter is going to be what we want to check. So we're going to do if, and you can't just do if like text, which is our second parameter, is equal to health. You can't do that, because that's not how text is a memory. You just can't do that with you just can't do it. You need to use string compare. So strcmp is going to compare the strings. So we're going to compare text to the phrase health. And if that if this is a bool, so it's gonna return either a true or a false, or a 1 or a 0. So if it is if string compare text to health is equal to 0, that means that we want to that means that it's actually that's the command we put in. If it's equal to 1, that means it's not. So we're going to check if it's equal to 0. So we're going to check if it's equal to true. And if the strings compare, if they're the same, which means 0, that means they're the same, then we're going to modify our health. So in the last video, I went ahead and found the health, but I'm just gonna find it again in this video. So let's just go over. I'm just gonna find the health, and you guys can follow along if you'd like. There we go. All right, scan for 58. Let's go ahead and check. Yep. All right, this is it. So let's go and find out what access is. This address. Yes. All right, so we're adding and comparing UDX, which is this. Add this. Plus 4. We have 66. So we have this. And we have this address too. Oh, wait, sorry. Let's just do this again. Right now it's not gonna work, but all right, so here we go. Now we found the correct player. When we scan it, we get the static player. So this should be our static local player. Okay. So, all right, now we have that. Sorry that took a little long. All right, so we have our static local player, so we can just start defining stuff. So we can go up here, uint pointer tr underscore t. First, we need our game base address. So actually, let's just do a d word. Route this to a d word. Yeah, module handle. And ac underscore client exe. And then we're gonna do a uint pointer underscore t pointer of local player. And we're gonna have it equal to uint pointer underscore t. And then we're gonna do module base plus, and then oops, this right here. There we go. So there's our player. And yeah, now we're pretty much good to go. We cast this to a pointer, sorry. All right, now we can define our health. So int health equals int pointer, and then dereference local player, and then we're going to add to local player the offset of EC, because you can see here this is EC, this is our local player. If you do this plus EC, or sorry, this plus EC, you get our health. Just make sure that you don't do this. This is going to give you a different address because it's going to make it a pointer. But yeah, if you make it a hexadecimal, you see it gives you this. So don't make it a pointer. Rookie mistake. Yeah, so we're going to add EC because this is going to give us our health. And yeah, now we need to dereference that to get the value inside. And we're going to set it to like 9 or like 6969. So this is going to set our health to that. And now we need to return print underscore original, because we need to return an int. Or yeah, we need to return, because yeah, we need to return to a function. And we're going to return health has been set to 999. All right. So yeah, and now we can go ahead and figure out what this is complaining about. Oh, we just need to, we need to return here. And by the way, returning ends it, so we're just adding the function here. So if this doesn't get called, which means if we didn't put health, if the game's trying to print something else, we're just gonna do the normal function, and I'm not worried about it. Yeah. So what's the problem here? Am I missing a semicolon? Am I missing colons in there? Oh, I know. Sorry. You have to take this out of your... This can't be in your main thread. So take this out, because you can't have two functions in a function. So just take this out, and also take all this out too. And just throw it above. And make sure you spell it right. Okay. Sorry, stupid mistake. Okay, so now we can actually create the hook with MinHook, because we have basically everything. So we're gonna do mh underscore initialize. You have to initialize MinHook before you create hooks. And now we're gonna do mh underscore create hook. This is to create a hook, and these are the parameters. So you need the target. So the target is going to be the target address that we're going to be hooking. So if we go to IDA, this is going to be the target address right here. Or sorry, not that. Sorry, this is going to be our target address. This is the print address. So we're going to convert it to the convention it wants, which is a long pointer void, a long void pointer, and throw this in here. All right, next we need the detour, which is going to be our hooked. This is going to be what it goes to whenever this is called. So it's going to go to our hook. And then we need the original function, and this is our trampoline. So we're going to just use reinterpret cast for this one, because this is the one that can actually crash our game. So we're going to just be a little safer and reinterpret cast of LP void. And we're going to cast it to the address of print underscore original, and make sure that we put a pointer here. And yeah, there's our hook. Now all we have to do is mh underscore enable hook and throw our LP void. We just need this, and we need this, and we're gonna throw the same thing. So it's gonna enable a hook, on this address. And yeah, that should be it. That should be our hook. So let's just go ahead and build, and of course I'll explain all of this after. And wait for this to finish. Hit inject. Okay, let's type in /health. Yeah, there we go. So you see it says health has been set to 999 from console. And our health has definitely been set to 9999 or 6969. I don't know why I said 999. All right. So yeah, there it is. Let's just explain everything that's going on here. So there's our hook. That's hooking functions for you. So here I already explained. We're comparing. We're returning. We're returning this because this needs to return. We're returning to our original. That this health has been set. So make sure you always need to complete your original if you're hooking. So the original function just can't ever be deleted. You always need to go back to the original, whether you're creating it manually. If you're doing that, you just do ASM, and then you can do assembly here, like this. But if you're not, then you need to just let MinHook do all the work. So we're here. If you type in health, we are defining health, setting it to 6969, and then returning to the original, but returning health has been set to 6969 instead of unknown command. And then we're return. And then if this doesn't work, then we're just gonna do the original and not do anything extra. Here we're initializing MinHook, which you need to in order to do that. It just allocates memory for it. We're creating the hook. This is the address of the hook. This is our own hook. This is our own function we want to run, and then we're just safely casting an LP void pointer to the address of our print original. So the print original is just going to store all the code for the original print function in this pointer, so we can just we can just reference back to it. And then we're just going to enable it by just putting in the address. So that is how to hook functions in C++. I hope this opened your eyes. I might maybe do a part 2 to this video, maybe show you how to do like custom teams or something, do something without strings maybe. That's just going to be more reverse engineering. But yeah, if you guys ever need help, I do have a Discord in the description. It's very helpful. A lot of people there will be willing to help you. I'm active on it all the time now. That's how you get my latest videos. I'll put some download links in there of stuff that you can't usually get, like maybe IDA. And yeah, I hope you guys enjoyed this video. Like, subscribe, turn on post notifications, and peace.